In this chapter, we will be analyzing rational expressions and equations. In this lesson, we will be solving rational equations.
Hi everyone. Alright, so in this lesson we're going to solve rational equations. Okay, so when we talk about rational equations, what we're referring to here, okay, is, well, an equation. Okay, it's got to have an equal sign in it. The things that we've been doing in the previous few lessons here have been expressions. We've been simplifying expressions, adding and subtracting rationals. This time around we're going to have an equal sign. Okay, so we're going to set up an equality, okay, between the left side and the right side, or at least we're going to work with an established equality. We're going to figure out what the value of x is, what the value of the variable is in the expression, the equation that makes both sides equal. And obviously in this case here, for this to be a rational equation, one of the terms in the equation has to be irrational. Now, normally how we do this, and this little point form, little set of steps here, this is actually a fairly good guideline for solving rational equations. This can be done in other ways for sure, but kind of over time, this seems to be the one that achieves the goal as quickly and without all the other little confusions that sometimes follow here. This is just a good pattern here. So we're going to factor each denominator. We're going to identify the non-permissible values, and this is important. All the way through, we got to identify those non-permissible values, and you'll see why in a bit here, particularly with some of the examples that we do. Then what we're going to do is we're going to multiply both sides of the equation by the lowest common denominator. And what that's going to do is, for us, is it's going to eliminate the denominator. Okay. What we want to do here when solving a rational equation here is our goal is to eliminate the rational portion of the equation. Okay, just like if this was a trig equation, we're going to find a way to eliminate the trig function somewhere in there. If this is a polynomial, if it's a quadratic, for example, we're going to find some way of getting rid of that square in there. It's the same thing. This is a rational equation, we're going to get rid of the rational. Okay, if it was a radical equation, we'd be squaring both sides to get rid of the square root in there. Okay, then what we're going to do at that point here, we should be working with a simple polynomial. And then we'll just use tools that you've learned before to solve for that variable here. But then at the end here, you've got to check your answers by comparing them with those non-permissibles. Because if one of the answers that you find is one of the non-permissible values, that's an extraneous root. You kick it out, okay? But if it's not, then it's an acceptable root. Now that's only going to jump out at you if you know what the non-permissibles are. So you got to make sure that you do that. Anyway, let's take a look at some examples. Okay, so here we go. Let's jump in. We're going to solve for x in each of the following here. So the first thing that we would normally do would be to factor the denominator. Well, to factor everything, quite honestly. You want to factor everything so that if there's any simplification that you can do, you can get it done right away here. But in this case here, it's already been factored. Let's state the non-permissibles. So I can tell that x cannot equal -1. Okay, because that's going to lead to an undefined value here. Here, I'm also going to get x cannot equal to 1/3. So as long as neither one of my answers, neither one of my answers, I don't know how many answers we're going to get, but as long as my answers don't include those numbers, I'm good. Now, my common denominator is simply going to be the product of those two factors, okay? Because there's no shared factors here, okay, at all. So we're going to multiply all of the numerators by the common denominator. So we're going to multiply that through. Now, I'm going to come over here. I'm going to do this relatively slowly. I have a very specific goal with this. I'm hoping that after a few examples here, you'll catch exactly what's going on here. But I'm going to multiply. Remember, I'm multiplying over 1. I can do this here. I can multiply this expression over 1. I can multiply this by the equation here because I'm doing it to both sides of an established equality. I know that these two are equal to each other. As long as I do this to both sides, they stay equal to each other. Okay? Sorry, I shouldn't actually be putting an equal sign here. More like an arrow. What I'm going to do here, and you couldn't do this, you couldn't do this with the expressions before because if you multiplied the numerator of a fraction by something, you've changed the expression. I've made it something different. Okay? Here, I am allowed to make this something different as long as you make both sides the exact same thing. So if I multiply through by that expression here, I get that. And now this is going to equal, the right-hand side will be 5 multiplied by x plus 1, 3x minus 1 over 3x minus 1. Now, I look at both sides of my equation here. Notice I've got an x plus 1 over x plus 1. I can cancel those as long as x is not allowed to equal negative 1. And I've already identified it can't. On the right-hand side, I can cancel the 3x minus 1. That's true. I can cancel those so long as x can't equal 1/3, and I've already established x can't equal 1/3. So what I've done by canceling those out here is I've reduced this to a polynomial. More than that, I've reduced it to a linear. Okay? So now, to solve this, it's quite easy. Multiply through by the 3, multiply through here by the 5. I'll bring the 5x over, and I do that specifically because I want the coefficient of x to be positive, so I'm going to bring that over to whichever side makes it positive. Bring the negative 3 over, becomes 8, and now I'll divide both sides by 4, and I get that x is equal to 2. Okay, that's my solution. Now, is that one of my non-permissibles? The answer is no, so that's a correct answer. X is equal to 2. Okay, so that's how we go about doing this. You multiply by that common denominator because I already know it will cancel the denominators on both sides as long as I'm using the common denominator. Let's try another one. 3 over x plus 1 over x plus 1, okay, is equal to 2. Again, my goal, first of all, is to factor, but everything is already factored, so I'm going to state my non-permissibles. X cannot equal negative 1 or positive 1. Now I'm going to multiply through by the common denominator. Okay, bear in mind that line there puts parentheses around the numerator and denominator, but specifically what it's doing here is it's keeping that x plus 1 together, okay, as one unit, one factor. This x minus 1 is held together as one factor. So x is, again, not common. Okay, I mean, common in the sense of like rabbits are common in Edmonton. You can see rabbits everywhere. You open the door, there's rabbits out there. But when I say common in this math context, I am referring to, okay, it as a common factor. So now I'm going to multiply by x plus 1, x minus 1, because the common factor here is going to be the product of those two. So I'm going to do the same thing here that I did in that last one, and then I'm going to start to speed up through this a little bit. So this is going to become 3 x plus 1, x minus 1, divided by x plus 1. Then we're going to multiply that common denominator by that second term, plus 1 multiplied by x plus 1, x minus 1, over x minus 1. And now I'm going to multiply the other side of the equation, that term. Because bear in mind, there are 3 terms here. Okay, 1, 2, and then on the other side here, I'm going to multiply each term by that common denominator, x minus 1, x plus 1. Now, in this expression, those two will cancel so long as I've established that x can't equal negative 1, and I have. Here the x minus 1s will cancel so long as I've established that x can't equal positive 1, and I've already stated that. So now I'm just going to distribute the coefficients through what I'm left with here. So on the left-hand side, I'll get 3x minus 3. Here the not equals. Sorry, not equals, plus. Here, the leading coefficient is just 1, so when I distribute that through, x plus 1. Over on the right-hand side, this is a little bit more complicated, but I recognize that x minus 1 and x plus 1, that's a difference of squares. Okay, those are binomial conjugates. So when I multiply those together, I'm going to get x squared minus 1. Multiplied by 2 is 2x squared minus 2. Okay, so this one's quadratic, so I anticipate we're going to get 2 solutions here. I'm going to bring everything over to the right-hand side because I like having the leading coefficient being positive. I'm just lazy and it makes things easier that way. So I like having it positive. 3x plus x on the left-hand side is 4x. Bring it over. Changes signs, negative 4x. Negative 3 plus 1 on the left-hand side is negative 2. Add 2, and it's actually going to cancel with that. So that's my expression right here. Now, to solve that, I have to factor it. it's only got two terms, so I'm thinking it might be a difference of squares. It's not, though, because these are not perfect squares here. So I'm just going to take out what's common. And now I'm just finding what makes those two factors equal to 0. So either x is going to equal 0 or x is going to equal positive 2. Those are my two solutions. Do either one of those match up with the non-permissibles that I identified? No. So those are my two solutions. Okay? Over here. 2x squared plus x minus 15 over x plus 3 equals 15. Okay, now I want to be factoring. In the previous few questions, I didn't need to do that. Here I do. So the very first thing I'm going to do is I'm going to factor that numerator. It's going to equal x plus 3, 15. I'm going to factor that numerator, so that's going to be 2x and x. My factors of 15 are going to be 3 and 5, but I need the sum here to be 1. It's negative, so one's going to be positive, one's going to be negative here. I need this to be x plus 3, 2x minus 5. Okay, now what I'm going to do here is I'm going to cancel those two x plus 3's, and I can do that so long as x is not allowed to equal negative 3. Okay? So I established that. But that reduces this down to 2x minus 5 is equal to 15. Bring over the 5. So I'm going to add 5 to both sides and I get 10. Sorry, 10. Can't believe I did that. Ignore that. That's crazy talk. 20. X is equal to 10. Sorry, that was what I was anticipating there. Because that is not equal to my non-permissible, that's the answer. Now, there are other ways that you could do this question. You could multiply through by that x plus 3 and then get 15x plus 45, bring those over, and then factor. It doesn't matter, but just be aware of the non-permissibles. Okay, right from the beginning, there was a non-permissible here that x could not equal negative 3. You would need to include that as you're working through this problem. Okay, now let's try this one. So again, my first goal here is to factor, but there's nothing here that really requires factoring, okay? Because there's only one term in each denominator there. So what I'll do right now is I'll state the non-permissible. In this case, the non-permissible just happens to be the same for each and every one of those. X cannot equal 0. Please bear in mind that that is not always the case. It's not always the issue that x cannot equal 0. So that's not a go-to response that always kind of works and covers your butt. In many cases, 0 isn't the non-permissible. Okay, and I understand where people get confused because you think, well, I can't have 0 in the denominator. Yeah, but sometimes putting 0 in for x doesn't mean putting 0 into the denominator. So you got to be careful with that. Now, in this case, though, to get the least common multiple of the denominators there, just take a look at those denominators here. Let's look, first of all, look at the coefficients. Between 15 and 5, what's common? Well, there's a factor of 5 there, so the factor of 5's got to be in my common denominator, but there's also an additional factor of 3 coming out of here. So whatever my common denominator is, I got to have both, so that means it's got to be 15. Every one of these denominators has got an x in it, but this one has got 2 factors of x in it, so at the very least, my common denominator's got to have 2 factors of x. You know that you've done it right when you can look at your common denominator and see every other denominator at least in it. Okay, so if I cover that up, okay, I got my 15x. Okay, if I split up that into x times x, and this is 3 times 5, I can see the 5x in there. And then if I cover the 15, I can see the x squared in there. Like that's all in there. Now I'm going to multiply all of my numerators through, but now I'm going to start to speed up with this a little bit here. Okay, so here's what's going to happen. When I multiply 15x squared by this term right here, I'm doing that and I know that my x squared will cancel here. So I'm going to be left with 15 multiplied by the numerator. Okay, it's just the x squareds cancel and then that 15 distributes to that x minus 3. In this one right here, the 15 will cancel. One of the x factors will cancel, and so I'm going to be left with another factor of x multiplied by the 11. And then when I distribute that 15x squared to this term here, one of the x's is going to cancel, so I'm going to be left with an x in there for sure. And then I'm going to cancel that factor of 5 out of the 15. It's going to leave me with a 3 here. Multiplied by this negative 2 will get me negative 6. Okay. Now, there's nothing wrong with expanding out each of those numerators with that 15x squared. Nothing wrong with that at all. It's just not necessary. So now I've got this regular old linear expression here. Okay. So if I multiply that through, that'll be 15x minus 45 is equal to, well, 11x minus 6x is going to be 5x. I'm going to bring that 5x over to the left-hand side here to make that 10x. And I'll bring that, bring the 45 over. You get positive 45. So x is going to equal 45 over 10, which is a terrible way of writing that. I would cancel out the factor of 5 in both of those to get 9 over 2. Okay. Now, is that equivalent to my non-permissible? No. So there's my answer. Let's take a look at the next one. Okay, so now we're starting to stray more into the realm of the questions that you're probably going to get on the exam. Stuff that requires a little bit of factoring. Now here, none of this requires factoring, but this one does over here. So this is going to be 1 over x minus 1. That's fine. There's not much I can do with that. 3 over 2x, again, that's fine. X plus 1 is okay, but 2x squared minus 2 is I can take out a common 2 there. But then I'm left with x squared minus 1. Now, because I want to kind of get this into that limited little bit of space that I have available there, I am going to factor that difference of squares right here. That'll be x minus 1, x plus 1. Okay, so that's what happens when I factor that 2x squared minus 2. Take out the common 2 first. That leaves me with a difference of squares. There we go. I can tell you right now that my non-permissibles will be x can't equal positive 1. X can't equal 0 all by itself right there. Remember, there's no addition or subtraction here, so it's 2 times something is equal to 0. Can't let that happen, so I can't let x equal 0 there. And then here it's going to be positive 1. I already got that. And then minus 1. So those are my non-permissibles, and I got to keep track of that, okay, or keep going back to that as I work through this. Now, my common denominator here, I'm going to put brackets around the entire equation. My common denominator's got to have a factor of x minus 1. It's got to have a factor of 2 and x. It's got to have a factor of 2, and it does, so I'm good. That 2 is covered. I've got to have an x minus 1 there, and it does. But I also need a factor of x plus 1, and this one it doesn't, so I have to include that, what's missing here. Okay, so now when I multiply this common denominator through the numerator, now not the numerator and the denominator, that's not how fractional multiplication works, and we've gone over that. Okay, remember, this is like it's all over 1. This is all going to get multiplied by the numerator. When I multiply this by this numerator, I am going to cancel out the x minus 1s, and I'll be left with 2x multiplied by x plus 1. That's what's left over. In this one right here, the 2x is going to cancel, and I'm going to be left with 3 multiplied by x minus 1, x plus 1. Okay, that's what's left over here. Now over here, over here, a whole lot is going to cancel. The 2 will cancel, the x minus 1 will cancel, the x plus 1 will cancel. All that's going to survive out of that is that little x multiplied by through, so x multiplied by x plus 1. Okay, that's all survived. Now I can cancel out all those denominators so long as x does not equal 1, 0, or negative 1. And again, I've already established that. So I'm just going to keep this in mind as I work towards my solution. Now that I've gotten rid of the denominator, all I'm looking at is a polynomial here. And now I'm going to expand that out. So I'm going to get 2x squared. Okay, good. Immediately I see this as a quadratic. That gives me a direction here. Plus 2x is going to equal, well, x minus 1 times x plus 1 is going to be x squared minus 1. Let's distribute the 3 through. So 3x squared minus 3 plus, and this is going to be x squared plus x. Okay, so let's have a look here. I've got a 2x squared here. I've got a 3x squared plus a 1x squared, so it's 4x squared. Okay, I'm going to bring everything over to the right-hand side. So 4x squared minus that 2x squared will be 2x squared. So again, all I did is I put together the 2x squared terms here, subtracted that 2x squared from both sides, boom. I have got an x here, and I'm going to move this 2x over, so I'm going to subtract that. It'll be minus x. And then I have this minus 3 left over. Okay, now I'm running into my next question here, so I'm just going to copy this up over here. So 0 is going to equal 2x squared minus x minus 3. All right, now I've already spent a bunch of time in this course factoring or solving equations like this. Now I got to factor it if I can. Now if I can't, I can use the quadratic formula, but we'll see how this works. This is negative, so I need my factors of 3 to both be, sorry, not to both be, but to 1 to be negative, 1 to be positive. And by the way, factors of 3 is either going to be 1 and 3 or 3 and 1. But then I need the sum to be equal to negative 1, so I can't be multiplying the 2 by the 3. I got to put the 3 here if this is going to work at all. To get a negative here, I need the larger to be negative and this one to be positive. So 2x times 1 is going to be 2x minus 3x. Okay, there it is. There it is. So x is going to equal either 3 over 2, positive 3 over 2, or negative 1. And there it is. Finally, a question like this showed up where, hey, I've got a negative 1 here, but I knew right from the beginning x couldn't be negative 1. So therefore, x is equal to 3 over 2. Okay, the negative 1 is extraneous. Okay? And negative 1 is extraneous. Now, by the way, just something to be aware of here. When you're working through questions like this, you could always use your calculator, right? Graph these things, look for points of intersection, look for x-intercepts, depending on how you set it up here. What you can't find using your calculator, at least not very easily, is that extraneous root. Okay? That's why sometimes you'll see them ask for the extraneous root, so that you're basically forced to go through a nice algebraic solution. Now, I'm not saying that you can never use the calculator to find the extraneous root. It's just that we're really not helping you out in that regard. Okay, we're not giving you tools to do that. Okay, and neither should we. Anyway, let's keep going here. X minus 3 is the denominator. Okay, in both cases, in fact, both times that x minus 3 shows up, it's in the denominator and there's nothing else down there. So I'm just going to identify my non-permissible is going to be that x can't equal positive 3. And now what I'm going to do is I'm going to multiply everything through here by that x minus 3 to get rid of it. Now, in that first term, it's going to cancel. I'm just going to be left with that 8x plus 10. It's kind of cool. Over here, there is no denominator. So when I multiply that through, it's going to be negative 4 times x minus 3. I just got to put that in the numerator. On the right-hand side, the x minus 3 is canceled. We can be left with 10x plus 4. And again, we're down to a polynomial. In this case, it's a linear polynomial. Okay. Distribute the negative 4 through. Negative 4x plus 12 is equal to 10x plus 4. Now, what do I got here? On the left-hand side, I've got 4x. Sorry, I already did the math in my head there. 8x minus 4x to get you 4x. Then I'm going to bring that over to the right-hand side. 10x minus 4x will be 6x. 10 plus 12 is going to be 22. I'll bring that over. And if I subtract 22 from 4, I'm going to get negative 18. Okay. Now here I'll take out what's common. And I get that x is equal to, whoops, I'll come up here. I get that x is equal to 3. Okay, just that's what the solution is right here. Now, however, my non-permissible was 3. So what this tells me, therefore, is that there's no solution to this equation. Now, that is an uncomfortable way to end a problem. Okay, most of us, when we're working through a problem here, we love to get, here's my solution. But that doesn't always happen. In fact, in a lot of cases, there's no solution to the equation that we're setting up here. And that's okay. During an exam, if that ever shows up, I really do encourage you, you should redo the question. You should go back through, make sure that you did that right here. But if you're again getting no solution as your answer, then that's okay to write no solution. Okay, that's very likely is the answer that we're looking for. Let's try another. Okay. Let's take a look here. Is there any little bit of factoring that we can do here? No, there's nothing that I can do to factor that, nothing I can do to factor that. My non-permissibles are going to be that x can't equal, bring the 4 over, divide by 3, so negative 4/3. And x can't equal negative 6. Okay, whoops. Those are my non-permissibles. So as long as I don't get those, I've got the right answer here. I'm going to put parentheses around these. And now, because I've just got these binomial factors in the denominator, when I look for common factors, I recognize there is nothing common here in terms of factors. The 3x plus 4 kind of sits on its own. That x plus 6 sits on its own. Okay, I don't see it duplicated anywhere else here. So when I multiply that through, by that first term, the 3x plus 4s are going to cancel, and I'm going to be left with 4x. And then what survives of the denominator is that x plus 6. Over here, the x plus 6s will cancel, and I'm going to simply be left with 3x plus 4 multiplied by 10. Now, what I like about this is when you multiply that common denominator by 0, you still only get 0. Love that. Love that property of 0. Man, that makes things straightforward for us. Now we're going to distribute this. We're going to get 4x squared. There's my quadratic, so I'm going to get possibly 2 solutions. Okay, possibly no solutions, but could get 2 solutions here. 4x times 6 is going to be 24x. Minus 30x minus 40 when you distribute that 10 through. So we've got 4x squared. What do we got here? 24 minus 30 is going to be negative 6x minus 40. Okay, I am exceptionally lazy, so I'm going to try to simplify this as much as I can. And the best that I can do right now is just divide everything through by 2. I can do this because it's an equation, as long as I do it to every term. Now bear in mind, on the right-hand side, 0 divided by 2 is still going to be 0. Now let's try factoring that. So 2 is going to get broken up into 2x and x. 20, immediately I think the factors are 4 and 5. And I might as well just write that out here, 4 and 5. If this doesn't work, then what I'll do is I'll just simply switch the terms around here and check another pattern here. 2 times 5 is 10, 4 times 1 is 1. There's no way I can combine the 10 and the 4 to get 3, so that's just not going to work. But it could have been 5 and 4, okay? 2 times 4 is 8, 5 and 1 is going to be 5. I can combine 8 and 5 to get 3, so long as the 8 is negative and the 5 is positive. And that's consistent with this multiple here. Now, just to let you know, when I guessed that this term was 4, that really wasn't a legitimate guess. Okay, I knew where I was going with it. I knew it wasn't going to work, but I wanted you to see me do that. But it doesn't make sense to guess a 4 here, because then I'm putting a common factor of 2 in this one, in this factor here. And there is no common factor of 2 in the whole thing. So I can't just introduce a common factor where none existed in the original problem. So anyway, you can still just go through and guess and check, and it'll be really quick here. So the solutions that I get here are x equals negative 5 over 2 from that first factor. Okay, that's good. That's totally acceptable. Here, positive 4. That's good too. So those are my 2 solutions, negative 5 over 2 and 4. All right, now one more. Now this equation right here, immediately my eye goes to something that I consider a little bit ugly. Okay, I don't like the fact that it's 2 minus x. I like it when the x comes first. So whoops. So what I'm going to do here is I'm going to switch the order. Just make that negative x plus 2. I like that way better. Okay. But now the next thing I don't like is I don't like having the leading coefficient in that little expression there, that binomial, being negative. So I'm going to factor that negative out. That's going to change the signs of everything. Now, I haven't really done anything with it. I've still put the negative down there. It's just out front. That way, in the binomial, the x is positive. But now what I've got is I'm subtracting a positive divided by a negative. Well, a positive divided by a negative is going to be negative. And when you subtract a negative, that's like adding. So that negative is going to come up here and change that subtraction into addition. I like that way better. I love the way this looks. I don't like the way it looked in the original here. So I'm going to keep working with this one. First of all, I'm going to state my non-permissibles. X cannot equal positive 2 or 0. Okay. So now I am going to, well, okay, to be honest with you, on the left-hand side here, because I see that I've got the same denominator on both of those, I can just add those together. And the numerators are like terms here. They're both just constants. So 6 plus 4 is 10 over x minus 2. It's going to equal 8 over x. And that was just so easy to do. Now I'm going to multiply by the common denominator, which has got to be, remember, x minus 2 is being held together as one unit, and x. So that's a factor, and that's a factor. When you multiply that through, in the first case, the x minus 2's will cancel and be left with x times 10. Over on the right-hand side, the x's will cancel, and you'll be left with 8 times x minus 2, which is a nice little linear. Multiply the 8 through, 8x minus 16. Bring the 8x over, subtract it from both sides, you get 2x equals negative 16, so x is going to equal negative 8 when I divide by that 2. Now, was that a non-permissible? Nope. Those were 2 and 0, so that's my solution. Okay, man, I hope that makes sense. I hope you're clear on that. So please make sure you're looking for non-permissibles. Okay, make sure you're comparing those non-permissibles to your final answer. Don't be scared to cancel factors to simplify as you go. Okay, if when you factor and you see in one term the numerator and denominator are the same, don't be scared to cancel those. But then the idea is to multiply through by your common denominator to get rid of the denominators. Okay, to convert it into a polynomial. And now it's going to be in a form that you're much more comfortable with. Okay, much more comfortable with. So anyway, I hope that helps.